Hi folks, here's another universal gravitational law question. Don't forget to like and subscribe if you are new here. Watch my video till the end, share with your friends and families. Thank you for subscribing, those who subscribed, and let's cut the chase. Now this one, it says consider a satellite orbiting Earth as illustrated in the diagram below. Here's an Earth, and then the satellite is orbiting, which means it's moving around the Earth, right? And at a distance. Now it says at a height of 7 times 10 to the power 5 meters, which is the height in which it orbits. It orbits at a distance of what? 7 times 10 to the power 5. Which is, that's 700,000. The gravitational force on a satellite is 7,980, which means the force that the satellite exerts on Earth is 7,980. Even the force that exerts on the satellite is 7,980. Now it says the Earth has that radius, that's the constant, guys. You have it in the data sheet as well, which means this is from the center to the circumference. That's the value right there. And then the mass of the Earth is that one, also in the data sheet. Now we'll just jump to 8.2, calculated the mass of the satellite. So calculating the mass of the satellite, we're using the formula F is equal to G times mass 1 times mass 2 over R squared. And then the force, we substituted the gravitational force, which is 7,980. And then we substitute the G, it's 6,67 times 10 to the power negative 11. And then the mass, it will be the mass of the Earth, mass 1, 5.98 times 10 to the power 24 times the mass of the satellite, I'll say ms. Guys, you need to remember here, so this distance is going to be here from here. So we're going to add this distance, which is the height plus the radius. There, it's very important. Okay, let me show it here. So it's going to be G mass of the Earth times the mass of the satellite divided by the R squared. It's going to be the height plus the radius of Earth square, which is, it's the radius of the Earth and the height there. So it's going to be, the height is 7 times 10 to the power 5 plus the radius, which is, it's 6,38 times 10 to the power 6 square, right? So it's very important. Now what do you need to do now in order to get an accurate answer there? So we're going to cross multiply. We're going to have 6.67 times 10 to the power negative 11. This times this, times 5 times 5,98 times 10 to the power 24 ms equal to, so we're going to cross multiply that and that. So it's going to be 7,980 multiplied by open bracket. Okay, let me move it a bit. Okay, so it's going to be 7 times 10 to the power 5 plus 6.38 times 10 to the power 6. Don't forget to square. And then what are we going to do? We're going to divide by this, both sides. It's going to be 6.67 times 10 to the power negative 11 times 5.98 times 10 to the power 24. And then we divide both sides by the same thing. 6.67 times 10 to the power negative 11, 5.98 times 10 to the power 12, 24. So that and that will cancel. So you have the mass of the satellite. If you punch that in the calculator, it will be 1,002,86 kilograms, right? I hope that makes sense, guys. That marathon of maths there. It says what will be the effect of the gravitational force exerted on the satellite if the mass of the satellite is doubled. So if the mass of the satellite is doubled, guys, that's 8.3. 8.3, the force is directly proportional to the product of mass, which is the mass of the Earth times the mass of the satellite. So if the mass of the satellite is doubled, okay, let me do this. So it's a product. So if the mass of the satellite is doubled, that means the product is what? Is doubled. It's Earth times satellite. So the new force will be now, so that it will be equal to 2F. So the force will be, the force, if you double the mass, the product of the masses, also the force will be doubled because they're directly proportional. So the answer here, it says choose, right, increase or decrease or remain the same. So the answer here is what? Is increase. I hope that makes sense, guys. Cheers. Bye.